we can definitely kick off today's event, which I think will be super interesting and about what's cool in video in 2020. So we have gathered different projects which can be thought of as the forefront in video technology, and we'll learn why soon. So welcome to today's event. Let's pick up where we left last time. So the last event that we did was about broadcasting cloud. It was our 5th event. This is the 6th one. And in that event, we talked about the different workflows that happen at the broadcast level in a OTT world, from CDN delivery to 1+1 for redundancy, and other interesting projects for the transition of broadcast in cloud, basically. So from that, how the industry is conforming to today's standards, then we go on what's happening in video in 2021. So we kind of selected a few topics which our experts will deliver today, and they will be about live. So live video is quite important, with also a virtual reality component to it. We have then data quality driven, so understanding and analyzing what's the video consumption at CDN level as well, and how your user enjoying the service. So very important. Also, we looked at interactive video and how the COVID pandemic has brought up new cool ideas on how to make interactive events online. Then we look at volumetric video and AR, and this will be something that's coming as well with the faster internet connections brought by 5G and gigabit internet, FTTH. Also, we look at something which is quite important in the video world, which is encoding, and it's like compressing a video asset so that it can be played as a smaller file with the same quality on many devices. And today we look at shot-based encoding, which we're defining as smart. So given these topics, we will now look at the speakers for today. So we will have Ryan Jespersen from Millicast. Hi, Ryan.
Hey, Andrea. Hi, everyone.
Hi, nice to see you here. Then we have Luca Moglia. Hello, Luca, from Akamai.
Andrea, and welcome to everybody. Ciao.
We have also Mr. Farr from Vimeo. Hello, Kieran.
Hello.
Hi, and we have Chris from TechSlice. Hello, and the scheduled player. Hi, Chris.
Hey, everyone.
And then we have Armin from Bitmovin. Hello, Armin.
Hi.
Hello, everyone. Good. So without further ado, I will introduce the agenda, and we will talk about OBS with native WebRTC and low latency. Ryan, talk us about that. Then we will look at data dashboard on Edge KPIs, and Luca will show something that he has been creating. We will then look at interactive online theater from Chris, and WebXR volumetric video from Kieran, and last but not least, shot-based encoding from Armin. If you have any questions, do post them in the chat. We will address them either at the end of each presentation or at the end of the event. So feel free to ask, and then we'll direct the questions to the different speakers. So having introduced an agenda, let's go deep down now in what's coming and what's available in video and what's cool in 2021. So let me introduce Ryan, and the floor is yours.
Perfect. Thank you, Andrea. And I'm going to go ahead and take control of the screen so you guys can see everything that I have here on my machine. Can you see my screen okay?
Yeah.
Perfect. So nice to meet you all. I'm Ryan Jespersen. A lot of you might know me from my Wowza days. I was at Wowza for about 5 years. So right at the heart of the live streaming industry, right, in the last 10 plus years. And I've been in digital video and live streaming for 15 to 20 years now. I'm originally from Spain, even though my name doesn't suggest it. And I used to hate Italy so much, I'll be honest with you. You guys kicked us out of the '94 World Cup in the US. I remember Roberto Baggio and all that, but I finally traveled to Italy a couple of years ago and fell in love with it again. So don't hold it against me because I'm originally Spanish. So I'm going to talk a little bit today about OBS. All of you probably know about OBS. It's probably the most popular software encoder in the world because it's free and it's an open source project. And what we've done is taken OBS and created a fork of it and embedded WebRTC directly inside of it. And we've done that to create full end-to-end WebRTC workflows on top of our technology, Millicast, which is a WebRTC platform in CDN. And so we're trying to really push a lot of the effort with WebRTC into the industry. And that truly enables kind of true ultra low latency workflows that give you sub 500 milliseconds globally at scale. That's really the effort and the technology that WebRTC is trying to enable, right, with a lot of us. So it's a good place to start is talking about the technology first. So with WebRTC, a lot of you, I don't know if you're aware, but WebRTC as of January, just last month or a month and a bit ago, January 2021, became an internet and web standard. And for a lot of people, you may think, really? Wasn't it already a standard? We've been using Google Hangouts and Google Meets and all these different technologies, but IETF and W3C had still not ratified it as an actual standard. So as of January, that became true. And what it means for WebRTC as a technology is because now every internet and web-enabled device to follow IETF and W3 standards has to have WebRTC 1.0 built into it and support it to be considered an internet-enabled device. So it means for anyone who wants to build a true WebRTC solution, they can now do that based on this standard. Before that, everyone was kind of doing whatever they want to do. And WebRTC, that's why you see so many different implementations, is because not everyone was following the same standard. And the same happens for signaling. A lot of signaling that happens with WebRTC, different platforms use different signaling, and it's so with these standards, this really helps for people like us who are building video solutions in the industry to go out there and build them. The other big thing that happened in January was the Alliance for Open Media is driving AV1, which I'm sure you guys are aware of as well. AV1, I think, is kind of the future of codecs and the future of encoding and decoding. Netflix already has most of their video on demand libraries encoded to AV1. So every device that's out there on modern silicon can decode AV1 and be able to play it back. And this is true of a lot of set-top boxes now and over-the-counter OTT devices and so on. And what's important is that Google Chrome has now enabled AV1 real-time encoding inside the browser. And so we had one of our engineers, Sergio Murillo. Sergio is based in Madrid, and he is a WebRTC god. He authored the Meduse media server, if you've heard of Meduse, and that's his baby. And he's got real-time AV1 working, and I'll talk a little bit more about that later. But the exciting thing now is with real-time AV1 and scalable video coding, you can now build that into your WebRTC end-to-end solutions. So you don't have to do adaptive bitrate like we've had to do in the past, where you send that through an origin server that transcodes. With SVC, you can now include the scalable video coding, and the sender side will intelligently choose that inside of the SVC codec. So AV1 SVC is actually enabled by default, as opposed to HEVC or H.265, where it's an option. So it really creates this amazing workflow for streamers, live streamers, who want to be able to encode in real time in the browser or hopefully in hardware with hardware encoders in the future, and not be able to re-encode at any part of their media pipeline. And that's a very interesting thing, because the minute you have to re-encode, the reason we re-encode is to create ABR, but with SVC, we get to mitigate and get rid of ABR and support it in a new way with a new kind of more advanced technology. And so with WebRTC being available in Google, Firefox, Apple, Microsoft, every major browser and mobile device, in addition to AV1 decoding, it really opens up, the time for WebRTC is now. And for a lot of people who come from traditional streaming like I do, we've been doing RTMP workflows and all these old traditional old Flash and other technology workflows. And WebRTC is really the first streaming technology built just for the web. And now it's becoming so predominant that it's being used for broadcasting as well. And I think that's a very interesting distinction. AV1 kind of makes WebRTC grow up to be a true professional workflow for even broadcasters. So this is the amazing thing about all of this. With this being a standard, every single internet connected device starting now forward has to support WebRTC, and many already do. We have an implementation with Apple TV already, and we have WebRTC ported to Apple TV. We have a lot of professional broadcasters producing TV shows and films and so on, who want really high quality 4K HDR 10-bit surround sound. And they want to do that over WebRTC because they want to share it in real time as they're doing post-production. I'm going to show that workflow in a demo here in just a little bit. The other amazing thing, I'll show a drone demo in just a bit, some footage. We have DJI Mavic Pro working, but the problem is WebRTC is still not enabled as an encode on the DJI Mavic. You have to use a mobile device and pass it through as an RTMP stream. But all of these devices in the future, Internet of Things devices, robot devices, all these things that connect smart cameras, CCTV cameras, in the very near future, many of them are actually going to be configured to use WebRTC natively instead of RTSP or other streaming technologies that we've had historically, because of the fact that latency is so reduced with WebRTC as compared to other TCP technologies. And why is this important? Well, what's important about this is the fact that what you're seeing, this big trend in streaming where we want to create interaction. And the only way you can create true interaction is by it being extremely low latent. You can't have, let's think, I have a lot of different use cases here, but one of the most telling examples is adult entertainment. These kind of free camera, these adult cameras that you're using to do real-time cameras, for adult industry. In that use case, you can't have a real-time use case with that use case and have a 3 or 5 or 10-second delay. The interactivity you're trying to build into your streaming workflow doesn't work. And that's true as well with what people are trying to do with live sports, with video-enabled e-commerce, with live auctions, with cloud gaming. You can't have any kind, if you've ever used an Oculus or anything like that, the minute you have more than a few milliseconds of delay, you create kind of a little bit of a bad user experience, right? And you get dizzy. All these kind of workflows crave interaction. And for you to do that, you have to do that with the least amount of latency possible. And the reality is we need less than a second of latency, probably even less than half a second of latency end to end with these workflows. And no other streaming protocol allows this workflow. People are trying to do that with RTMP. RTMP is going away from a playback protocol. People are trying to do that with low latency HLS. It just isn't built for what this is, but WebRTC is. The interesting thing about this is that all this interactivity will unlock many multi-billion-dollar markets coming in the next few years. And remote production is a very good example. You saw an Emmy Award given to a few remote production companies that are customers of ours that were allowing people to do real-time workflows with Adobe Premiere, with Avid Media Composer, and they want to do color grading with color graders all over the world and work on post-producing real-time shows. That's become a real thing in the world of COVID, where people can't go into the movie studios. And I'll show an example of how to do that with Premiere and NDI in just a second. And these are just a few of the other examples. Betting and gambling, you can't have more than a second of latency because of the possibility for fraud with betting and gambling. Health and fitness, you have people trying to build interactive gyms and interactive Peloton is a good example. If you're doing a live class, you can't have more than a second of latency for people to truly interact with at-home gym environments. And then you've seen with Netflix, Hulu, Disney, they've all launched these watch parties where you're watching a single stream. It could be even a VOD stream, right, coming off of those services. But the WebRTC is being used to create watch parties of family members who want to join together. Samsung, LG, a lot of these smart TV manufacturers are building WebRTC functionality into the TVs so people can actually do watch parties. So there's a ton of different things happening with this. And like I mentioned previously, to truly be interactive, media has to be, if you want to make it two-way, you want people to be able to go from active to passive viewers like you can inside of Zoom. Well, there's 4 real things that you have to do inside of a technology to do that. You need to be real time, less than half a second of latency. It needs to be high quality, not just web quality, but also broadcast quality. It needs to be web scale and be able to scale to millions of concurrent viewers. And it needs to be secure with true end-to-end encryption. And WebRTC is the only technology that right now is offering all of these things at the same time. People have found ways to scale it. They've built end-to-end encryption where WebRTC is encrypted at the source and not decrypted until playback, which doesn't happen in traditional streaming workflows right now. And broadcast quality with AV1 is now enabled, so people can start building HDR and 444 color and 10 and 12-bit video. We're working with Dolby Vision right now to build Dolby Vision into these workflows as well. So WebRTC is really growing up as a true broadcast quality streaming protocol. So what I'm going to show real quick is a couple of demos using OBS and using native WebRTC encoding to send that through the Millicast platform. You could use this workflow to send it to Janus and to other WebRTC platforms as well. But obviously I'm from Millicast, so I'm going to show you how to use that. And we've built kind of a platform to be able to scale this. But the big thing I want to focus on here is the fact that you can do this with software encoders like OBS. That's an open source project, and I'll give you the link to be able to download OBS and go play with this yourself. So my first demo, I'm going to show Adobe Premiere. And I'm going to be doing a nice high quality feed, pulling that locally on my network over NDI into OBS, encode that source along with my camera, and then send that to Millicast to scale, and then give you guys a playback URL so you can view this on your own devices over WebRTC natively. The cool thing about this is that to play this back on your browser through Chrome, Safari, even on your mobile device, you don't need a player. You don't need to download a third-party player to be able to do this. The browser is natively able to do this through HTML5 and through WebRTC playback, which is amazing because you can control the playback experience all just with HTML and CSS. Okay, so let me go ahead and jump over to my demo. So what I have going on here, I have an Adobe Premiere project, and I'm going to go ahead and mute my audio because I always get this audio playback. So I'm going to go ahead and start playing this back. So here's my live video feed in my timeline coming off of Adobe Premiere. Now, inside of our version of OBS, you'll see here, I have my OBS or my source that I'm pulling in as an NDI source. And you'll see that's coming off of Adobe Premiere, and I'm adding my screen, my video capture. This is exactly the same functionality that you get inside of OBS. The only thing that we've done is added the WebRTC stack inside so we can communicate directly to any WebRTC platform and our platform through this technology. So if you're familiar with OBS, you see here are my different layers. I can turn on my video, I can turn off my NDI source and add my screen capture. There's a lot of different things we can do in here. And I'm going to be showing a 360 demo here in just a second as well. So all I need to do now is connect this to Millicast. So let me move my Zoom window here so I can see my browser. Here we go. So what I've done is I've gone to millicast.com and I've created a few tokens. And you can just go to millicast.com and create your free account. And I've already got a token here created for OBS. And I'm going to go ahead and click on that. And in fact, I'm going to go ahead and select this one here. And if I go into API, all I need is the stream name and the publishing token inside of OBS to be able to push this from OBS into, sorry, I've got my cameras on here. Here we go. So I'm going to choose settings. Inside of here, I'm going to stream this to Millicast. I'm going to type in my stream name, and I've got my publishing token that I pasted in there as well. Now, currently, I can only do VP9, VP8, or H.264, but we are working on AV1 as well inside of our own native SDK as well. And the other thing I'm going to do here is just check the output. I'm going to send this at 2.5 megabit per second, just because I have some bandwidth issues here locally at 1080p. So I'm going to hit OK, and I'm going to start streaming. Now, as soon as I do that, you can see now it's encoding my feed. And I do notice here that because I have a few things going on, my NDI input is very pixelated. That's my local NDI on my network, not OBS encoding or Millicast. So my camera here you can see is good quality, but this NDI source, because I have Zoom running and a few things running, I think it's taking up all my resources. But what I'm going to do now is share with you the playback URL. Inside of the same API window here, you can see I have a hosted player path. And I also have some embed code. So I'm going to copy that and I'm going to play this back directly in browser. So all I have to do is play this back, and we have like a hosted player that works. And you'll see now my NDI source with my camera running in the browser. And what I'll do is I'll share this inside of the chat window so you guys can all pull this in on your end as well. So here we go. There's the viewer. And now you can pull this up on your own browser and be able to see this live feed directly coming off of my machine. Now, real quick, I'm going to jump into the next demo just because I'm very limited on time. I want to be conscious of my colleagues and make sure everyone has enough time to present. So the final demo I'm going to show is come back into OBS. And what I'm going to do is actually turn off NDI and video, and I'm going to add this media source. And this is a 360 pre-recorded 360 source that I'm now going to simulate as a 360 video inside the browser. So one of our engineers built this version. This is in GitHub as well, and I'll put this link here. This is a free source in GitHub. And then we also have the GitHub project for the OBS WebRTC, which I'll share as well. But what I've done is I've pulled up this player. And inside of here, I'm going to put in my token, my account ID, and my stream name, and I'll be able to play back this Millicast stream directly in here. So I'm going to copy my account ID. Oh. So there we go. Put that inside of here. My secure token. And my stream name, which is right here. If I come back to OBS, let me actually replay this. I actually didn't have this set. So there we go, to loop. So there it is. It's streaming in real time. And if I come back in here, you'll see now I have a 360 demo. Now, the cool thing about this is that I can actually enable the audio. And here I can now scroll around. And here's the playback URL for you guys to play this back locally as well. So let me pull up the chat window. And the cool thing about this is that the 360 playback is actually happening in browser. So once again, I don't need a third-party tool. And let me start the playback again. I think there's a way I can loop this. Here we go. So now you guys should be able to come here and be able to see that 360 playback directly inside the browser. And you can see here, I can kind of move around. And you can do this with a live source too. So we have this working with a Ryko Theta 360 camera, pulling it in through RTMP and restreaming it. But the amazing thing about this is that you could be live streaming a 360 feed from a camera in real time, and then be delivering it to the browser. And using this plugin, you can deliver this whole inside of here. And that's pretty much it. I've taken up, a little bit too much time, but I wanted to kind of give you guys a little tease as to what's going on inside the product, and then inside of WebRTC. And I think it sets it up nicely for a couple of other demos that are coming later on that talk more about WebRTC. And then I did a presentation, a 3-hour workshop on all WebRTC last week for streaming media, Connect. And I'll share that URL in the chat window as well. So you guys can visit that after this session. And if you want more information on a lot more about WebRTC and things that are happening in the industry.
Thank you so much. Really interesting. And I like the 360 stream from the browser. So thank you, really. And if anyone has any questions now or later, then feel free to write them in the chat, and then Ryan will reply to them. So, having said that, I think we can go to the next speaker. And again, really interesting. Okay, we got one question. Is what is the latency you obtain with Millicast? From Nassim.
Yeah, so with Millicast, if you use WebRTC natively, on average, you do under 500 milliseconds end-to-end from source to playback. And that's globally at scale. So we have some live auction customers who have done 1 million concurrent viewers on one stream and still been able to get under 500 milliseconds end-to-end. So if you have to do RTMP, we do ingest RTMP. That adds a little bit of latency. And a lot of times you have to configure RTMP to reduce things, to optimize it for low latency delivery. But we have recommended settings for OBS and Wowza and other RTMP sources and other encoders as well. But WebRTC end-to-end, we on average see 200, 300 milliseconds end-to-end with our platform.
Okay, thank you very much. Klaus says, nice, and thanks for the demo. Awesome. Okay, We have, oh, okay, you're sharing the link. Okay, nice.
Yep.
Good idea. Perfect. So having said that, I think that we can progress to the second speaker, which will be Luca. So Luca, if you want to share your screen and the presentation, then you can kick it off.
Yeah, thank you, Andrea, and very good, Ryan. I enjoyed it very much.
Thank you.
So I'm sharing my screen, and I just posted in the chat a URL with a video. So let's say that the demo that I'm going to show, because I don't have any slides apart of this, that is my name and surname. So I'm Luca. I'm from Italy, from Akamai. I'm working in Akamai as a solution engineer. And today I would like to show you some nice data dashboard based on edge KPIs. So really, we are not speaking about here about client-side KPIs, so to like Conviva, Nice People at Work, Max, that are so great, but we are speaking about reading the edge logs in a kind of way that are similar to the client-side KPI. So if you can just click on the link that I just shared with you, it will play a nice video of Big Bug Bunny that I'm sure that we all know. And I will start sharing this dashboard. So here it's really not really a demo of Akamai. I will speak a little bit of Akamai, but it's mostly some nice way to build a data dashboard based on the edge KPI. So we see that here we have some guys from Milano, from Obervis, from London, from Vanta. I'm from Vodafone, so the other one in Milano should be connected via Fastweb. So you see that basically here within 60 seconds, so really within 1 minute, oh nice, we have somebody from US as well. Maybe it's you, Ryan. So it's very cool that within really, it's a matter of seconds, it's a matter of minutes, we can really have all the logs, in this case from this stream from Akamai, pushed to an aggregator, that in this case is Datadog. So you see here that basically you can, let me expand it a little bit. You can have on the right all the logs. So we can see here that, for example, in red could be an error, could be a 404, a 500. We can then investigate a little bit more. In green should be a 200, so it's the request has been served incorrectly. And then we can build a lot of other nice graph. Of course, the geo stuff is very useful, is very cool. We can also relate the kind of error. So if we got 500, for example, you see here that some of you had a 500 error. Maybe we can relate that error to the geo, so to identify if on the CDN of the edge or the edge we are having some issues in specific geos or specific location. And then the interesting stuff is that we can implement some log count by HTTP URL. In this case, it's a simple multi-bitrate stream with just 2 bitrates. If I remember well, 720, 1080. You see here that basically we can have in this path the number 3 on the number 2. So most of you are playing number 3, that if I remember well is the highest bitrate. So based on that, we can even calculate the most common bitrate, the average bitrate that all my clients are consuming. And this is really live. So you see that basically the latency is really 60 seconds and so on. Then, of course, at the bottom, we can have a little bit of additional information. So I'm looking at, for example, user agent, and then I'm doing that to have the device brand, OS family, browser family. So I see that most of us are on Apple, Mac. There is also some Windows, Linux, Chrome is the most used browser. And then here is something that I need to show you a little bit better, because let me explain. Here I'm trying really to calculate the download time per single segment. Let's say that here I would like to recreate a kind of rebuffer rate that on the client-side KPI like Conviva or the other tool that I just mentioned, we have, I would like to create that on the edge side. So if we know that a given segment or all the segments of a stream are that the segment length is 6 seconds, 10 seconds, 2 seconds. Here, basically, with that, I can say if the download time is less than the segment length, then there is a very low probability that I will have a rebuffer. So basically, here I displayed all the download time. You see that it makes some sense, but of course, there is always room for improvement. Then here I'm basically listing really simply the cache hits, that in this case you see that the cache hit versus not going back to the origin to ask the content. And here I'm looking at the network throughput that is based on the Akamai data. So basically most of us are on a VHI connection that is if I remember well, more than 5 megabits. Somebody is also on a low connection that, if I remember, is around 1 megabit per second. So really, this is a way to show in a different way the logs. Let me show really what is a log in this case from the Akamai platform. In this case, I'm using a solution that is called DataStream that is capable of pushing the logs in real time to a location. We are supporting today AWS, Azure, and Datadog in push mode. And here in Datadog, I'm receiving all the logs, as you see here, and I'm aggregating all the logs to display this KPI. So if I basically click on a log, you see that here, sorry, there are the photos. You see that here I will have all the details about the information that are included. For example, we were speaking before about user agent. Yes, I have the user agent. For example, I have the path. I have the netperf data, and the load time is the one that I'm using to display the data in the dashboard. You have the autonomous system name. So you have really a lot of data that you can use in the way that you would like to. So basically, when you would like to use a data, for example, the throughput, you can just click on it, and you can create a facet. In this case, I already have one facet based on network throughput, but of course you can create one, and then you can import that KPI in the dashboard. So the goal, what is the goal here? The goal is really to complement, first of all the client-side KPI, because as you can see, and I'm sure, as you know, we do have many devices, including the laptop, tablet, mobile devices, and basically the way that it's working today is that there is a piece of JavaScript or an SDK on the client that are collecting data and sending all this data to an aggregator that usually it's from Conviva, Max, and as people at work, even Bitmovin, and this aggregator will of course aggregate all these logs, creating these KPI like rebuffer rate, video startup time, all this kind of KPI. But it's also important right now to have visibility on the full chain. So really starting from the encoder, for example, on the video origin, on the edge platform. And today I really focus on the logs from the edge platform. So really here we have the classic cloud, in this case of Akamai, with all the logs. And all these logs are really able to send live all the logs that we are collecting to an aggregator, to an external aggregator that in this case is Datadog. So here it's really a simple push. We are going to send really raw logs. We are not going to, in this case, we are not going to aggregate the data. And in the future, so the next version of that DataStream will be able to support really a very huge quantity of data, so really hundreds of gigabit per second. Of course, if you don't want or don't like to use Datadog, in this case, I just use the free license. So of course, you may need, if you like to implement that, to use an enterprise license. You can even use the simple AWS or Azure storage, and then on top of that you can create some nice maybe Kibana with Grafana dashboard in order to display the data in a nice way. Then after that, what we can do, you can basically have really a full visibility across all the chain. You can have a client-side KPI, you can have edge KPI. Of course, you can even integrate, for example, in Datadog is really simple, the origin KPI. If you're using, for example, I don't know, Azure, you can create again, you can integrate this KPI in your aggregator here, and even the encoder KPI. So really the goal is to have one concentrator, one single point of contact to manage, to create even alert, because of course you may want to create an alert if, I don't know, you have a status code that is more than 10%, if you have a geo that is not responding responding in more than 10 seconds for the download time of the chunks and stuff like that, you will really to create a single dashboard that is really collecting all the data. And this is really something that, let's say, I'm interested in. I would like to promote and integrate the edge side KPI that, of course, it's where we have most of the data, because basically each single connection, it's really collecting a lot of logs now, because each get, each post of the chunks of the TS, of the M3U8 or the MPD or MP4, if we're speaking about Dash, is really create one single log from Akamai to be pushed to an external data aggregator. Yeah, so basically this is what I wanted to show you. If you're interested, of course, I can share the JSON of my dashboard. So if you're running, I don't know, even a streaming project, you may want to have a look to what I did. And here, of course, we can even have a look to data retention in the past. So for example, 1 month ago, you see that here we did some tests. You can zoom in. I would say it's really powerful. So I think that my time is over. Back to you, Andrea.
Thank you very much, Luca. We have one question from, actually 2 questions from Klaus. One is regarding cost and also cost reduction. Can you sample on the data stream?
So on the data stream one, I'm sure that we can sample. So you may decide to push just 50% of the data. On the new version data stream, I tend to say yes, that you can even sample on that side, but you cannot aggregate. So we are not able to aggregate data on the new version data stream, but I think that you can sample data on the new version.
Okay, thank you. And the next question is, what cost would you see for 100K streams over 1 hour, Datadog cost and also data stream?
So on Datadog, I cannot really answer, because I did the free plan that will expire soon, I guess. So I would say that it really depends by data retention. So if you like to keep the logs forever for a specific time frame, if you like to integrate just the edge logs, origin logs, AWS, Google. So on Datadog, I cannot really say. And even on Akamai side, let's say that we are discussing how to position this functionality. So for the moment, I cannot say anything, but let's say that I think that we will find a good way, let's say, to promote the usage of these real-time logs into our clients' workflow, let's say. So okay. Just to be transparent, I think that we will have the LA, the limited availability, end of March of Data Stream 2, where we can push really a huge quantity of data, while Data Stream 1 it's already in production. So.
Okay, so for, let's say, more or less, for I don't know about Datadog, but for 100K streams over 1 hour, can you have a ballpark length, more or less, or?
No, I think that it's too difficult. Then, you know, I'm not really assessed.
Depends.
It depends.
Yeah, for sure. So it will depend, of course, on different parameters, quality, and so on. But
exactly.
Yeah, it will have it will be a cost. So I think that's an interesting visualization of data coming in. There is a comment by Babak, and he says Datadog is pricey comparing to other options like New Relic.
Okay.
Okay, thank you for sharing the information.
You see, it's
And,
good to have a community so that we can share information.
Absolutely. Sharing is caring. So that's great. And I think also interesting to see all the data aggregated here. Really, really useful. Also for quality of experience, which is something that it's paramount in our world. So I think that's quite good for instrumenting and then taking business decisions.
Yeah, exactly.
So,
And Andrea, let me add that of course there is still a lot to do. So I did that in basically one evening instead of watching Netflix. So it took me basically a couple of hours to do that. But of course, if there is the need to have the dashboard, something like that, it would be my pleasure. And even if somebody for the community can help me in having a better visualization of the download time, for example, or having a better aggregation on the log count, so we can have a percentage of time of people spent on a specific bitrate, this would be great, I think.
Yeah, you can definitely then create a lot of interesting analytics examples to use in then driving the business. Awesome, great. So with that, if anyone has any other questions, do write them. We'll pick them up later. And let me introduce Chris. Hi, and he will be the next. Hello, he will be the next presenter. So if you want to share your screen and show us what we had a peek at the other day. So,
all right,
looking forward to it.
Cool, thank you. My name is Chris Uehlinger. I'm a developer at TechSlice, and I'm a co-founder of The Scattered Players, which is an online interactive theater company, which we started a year ago, and that's what I'll be talking about today. So a little bit of background. I have spent the past couple years doing projection design work for local Baltimore theaters. And because I'm a programmer by trade, I often try and work technology into the stuff that I design. So this is an example where we were using ARKit to do sort of live motion capture for some characters in a show. So now if I go to the next slide, there we go. This is an example where we were using WebRTC, which I've used for a fair number of shows to do sort of live stream stuff. In this case, what we were doing was we had two characters on stage having a conversation with another character played by an actress who was standing in a stairwell nearby. And they were able to communicate live via WebRTC. And, it allowed for a more live experience than what you would have if you had pre-recorded this video and the actors had to time their stuff against it. Instead, they could actually react in real time and create a more authentic performance. I've also used WebRTC to create monitoring systems for theaters and for shows. This was a case where the band was for a musical was backstage and needed a monitoring system so that they could see what was going on stage and pick up their cues and things like that. So I built a monitoring system for them that actually used Janus, which I'll get to in a moment. So I've actually used WebRTC quite a bit, even in brick and mortar theater. But the thing is that starting in March 2020, for reasons that I think are probably pretty obvious at this point, all of my spring productions got canceled. So as that was happening, I had an idea for an online immersive space sci-fi kind of show. I was trying to think about how could we do theater online and how could we make it more live and interactive than just a Zoom theater thing, or some people were talking about pre-filming things and live streaming them, and I wanted to try and find a way to do things in a way that would be actually live. So the concept was basically that the audience would be split up into groups and they could explore a solar system full of planets, and each of the planets would have a character played by one of our actors. The actors themselves would devise and create the characters and the worlds. The audience could go around and meet them in any order, and they could, solve puzzles and complete quests and things like that. So I approached some friends in the theater community. We got to work on building this thing and casting it and directing it. Over here, this video is of the navigation screen where you can choose which planet you want to go to next. So over the course of about 10 weeks, we assembled a cast of over a dozen actors We devised and rehearsed the show, and I built the platform through a process of like rapid prototyping and working with the directors and the actors to come up with a system that would work for them. Our show, Shattered Space, ran for 5 weekends in June and July 2020, and we followed it up in October with a magic fantasy themed show called The Battle of Broken Mirrors, and we're currently producing a show called Welcome to the Hotel Fantastic, which goes live in a couple weeks. So over here you can see a video of like, I've interspersed clips from the 2 different shows, but you can see that sort of like the actors are, you know, are performing. They get like the sort of the main stage area of the app, and all of the attendees are along the bottom. So the general sort of UI paradigm is similar to Zoom, but you know, we're incorporating things like 3D graphics and, you know, filters and things like that. And we have total control over the platform, so we can theme it, you know, and stuff like that. And I'll get to what that is there in a moment. So yeah, having total control over the platform, being able to sort of just like work with, you know, real-time video as like, you know, just another tool in our toolbox was really powerful. So having explained, you know, the concept, I'm going to break down the, you know, how we built this thing, and I'll go more into depth about how we did video and some of the cool effects that we did. So the platform that I built was called, we're calling it Promenade. We've open sourced it, and all the code, as well as a DevOps repo for deploying it yourself, is all available on GitHub, and all the links that I'll post in the chat afterwards. So the front end consists of 3 web applications, 3 single page apps, an admin app where the like stage manager can sort of control the show. They can, you know, play like the intro cinematic for people. They can, you know, keep an eye on, you know, if any users are having errors or issues. So there's that, the admin app. There's the actor app, which the actors use to actually perform the show, and the attendee app for anybody who's coming to see one of the shows. The web tech that we're using, obviously WebRTC. For the 3D stuff, we're using WebGL and off-screen canvas. We're using the Web Audio API, which I'll get to in a moment. And we're using WebSockets to sort of keep the state of all of these applications in sync. In terms of libraries, we're using React, Redux. We're using Redux Saga. If you're making a React app and you want to use WebRTC, I highly recommend Redux Saga. It's great for incorporating, you know, things that have side effects with your React app. We're using Material UI as our UI framework. We're using Three.js for the 3D stuff, and we're using Janus.js, which I'll get to in a moment. For the backend, we're using Express, MongoDB with Mongoose. We're using pure WebSockets and not Socket.io, and our authentication is done with JSON Web Tokens. We basically send all of the attendees an email with a login link that has their token in it, and they just use that to log in. We don't have usernames or passwords or anything like that. We pull ticket sales from Eventbrite's API. We send login emails manually. In terms of how we deploy the thing, all of the single page apps are deployed to S3 and served through Cloudflare. Everything else is deployed through Docker, Terraform, AWS EC2, and we use Let's Encrypt for SSL, and our video server is Janus. So if you want more information on all of this, I have a blog post that I've written that goes in depth on all of the other stuff, and I'll post that in the chat afterwards. But let's talk about specifically the video aspect of this. So I want to explain what an SFU is real quick, just for folks who are less familiar with WebRTC. When you take a lot of WebRTC tutorials, they talk about WebRTC being peer-to-peer, meaning that like, oh, you can, you know, take your video and audio data and send it straight to the person that you're talking to with no server. And that's fine if you're doing one person talking to one person. But once you have like a room with 5 people in it, it starts to become a bit expensive. So over here you can see, this is a diagram that I got from Blog Geek, really great WebRTC blog, if you haven't heard of that. Over here on the left, we've got an example of a mesh network where everyone's sending their streams peer-to-peer. And that means that if you've got like 5 people, you're going to need to send out 4 copies of your stream, 1 to each person, and you're going to need to receive 4 copies of, you know, 1 for each other person. This can be very difficult for a lot of people who have like data caps on their upload speeds. And so it can be, you know, it can make it difficult once you have, you know, that many people in a room. So in terms of solutions for this, there's something called an MCU. This is something that I think was popular before, but I feel like it's less used today. What you're going to come across more is this thing over here, selective forwarding units, or SFUs. This is where you have a server that's in the middle of everybody. Everyone sends their stream to the server, and the server copies it and sends it to everyone else. So everyone still has to pull down 4 streams, one for each of the other participants, but they only need to send 1 copy of their stream, which is easier on people who have, you know, slower upload speeds. And it just makes it a lot easier to, you know, scale up a WebRTC application. The other advantages too is that you don't need to use, you technically don't need to use stun or turn, which are some of the things that come up when you start learning about WebRTC and how to establish connectivity between users. If you've got a server that's already out there in the cloud, you don't need to worry about that stuff as much, because all of the users are going to be communicating directly with that server and don't need to do any weird tricks to communicate with each other. So Janus is the server that I'm using for this purpose. It's a selective forwarding unit. You can find more information about it at janus.conf.mediaecho.com. It's actually made by a startup in Italy. Shout out to the folks down in Napoli. So Janus is a selective forwarding unit, and it has some extra plugins that allow WebRTC to work with other protocols like RTP or RTSP for streaming, or SIP for sort of interfacing with older like voice over IP infrastructure. So it's also a great solution for if you're trying to find a way to like take legacy infrastructure and like make it work with more modern like WebRTC stuff. As I mentioned before, it gets rid of a lot of the need for stun or turn servers. There's some cases where you might need them, but for our use case, we didn't need any at all. It's free and open source. It's licensed under GPL v3. It's lightweight. It can run on really small VMs. We've gotten it to run on, if you're familiar with the EC2 sizes, we've gotten it to run on T3A nanos, and we've gotten it to cross-compile for ARM. It just does that out of the box, which is great. If you're familiar with what's going on in EC2 right now, T4G micros are actually free for this month because they're new. So getting stuff to deploy on ARM reduces your costs quite a bit. The team behind it is great. They are really dedicated to maintain this project, as you can see from this incredible commit graph. They've been working on it for years. They keep up with the twists and turns of the WebRTC spec as it changes. And so they've already started working on things like, I think they already have support for insertable streams and end-to-end encryption and stuff like that. So they really like WebRTC a lot, and they're really into it. Janus is awesome. I really recommend checking it out. This is not an ad. They didn't pay me to say this, and I'm certainly not saying it because I'm, actually the maintainer of Janus in disguise as an American. It's something. It's just that it's something that I've used for several years and that I really like a lot. And if you're new to WebRTC and want to try and build something on top of it, it's something that I really recommend checking out. So, as my last part of this talk, I want to go into a bit of like some of the cool things that we've done on top of WebRTC, some of the stuff that's not always covered in like basic tutorials. WebRTC, it accepts anything that can be a media stream in the browser. And you can make media streams out of lots of things. So you can actually combine WebRTC demos with demos of other APIs, like the Web Audio API. So the Web Audio API supports a ton of real-time effects. It can take any audio HTML element, or it can take media streams like microphones as input, and it can output to audio elements or media streams. And so you can take someone's audio, you can, put distortion on it or shift the pitch down, and then send that over the RTC peer connection to the other users in the group. I've got a URL here. This is an example of a web audio demo that does this effect. The other thing that we've found about WebRTC is that it's actually not as bad for music as you might expect. A lot of times when we're using real-time video and audio, the audio is being just super compressed and crunched down. But if you are willing to have a little bit of a higher bit rate, WebRTC can actually support like pretty good quality music, especially if you're using Opus's music profile as opposed to its voice profile. It can, handle things a lot better. I've worked with composers on these shows, and they've been pretty happy with the quality of our music. Opus and WebRTC actually even now support 5.1 surround sound. And if you Google FOSDEM WebRTC musicians, Lorenzo Miniero, the guy from the last slide, has a talk about this that he did a few weeks ago, where he goes in depth about some of the cool things that you can do with WebRTC and music. So check that out if you're interested in more information on that topic. So you might think like, okay, you can do cool effects on audio and then send that over the wire in WebRTC. Can you do that with video? Well, you can. And before I get into these effects, I'm actually going to quickly show this thing. I hope that this works. This is something that you can do with media streams. Is it going to pull my camera? It might not. It might have trouble right now. Ah, bummer. Okay. Well, Shader Booth, check this out. It's a thing that does really cool effects with your camera feed. And it can, yeah, the cool thing about this, it uses WebGL and shaders and things like that. It also uses some TensorFlow stuff to like get the position of your face. If your users have like good graphics cards, Shader Booth is a really cool thing that you can use to take advantage of that. And just like how you can take you know, an audio element and turn it into a media stream, you can also take a media stream from, you know, video, pipe it into a canvas element, do some WebGL stuff, then you can do canvas.capture stream to make a new media stream out of that. So you can stream not just the user's webcam, but anything you can put on a canvas. That's a whole other talk though, so I'll save that for another time. Instead, I want to talk real quick about some of the things that we've done with filters that are a little bit less intense on your computer's GPU. CSS filters are really cool. They are really well supported at this point. I've got some options here that you can see. You can do things like blur effects, you know, change the brightness or contrast, invert colors. You can even combine filters. And I don't know if you can see it down there, but there's a thing that says backdrop filter. That's another cool effect you can do as well. As you can see, we're doing it here to create like a crazy weird effect. And you can apply this to video elements. You can apply it to any HTML element and create like really cool filters that run on even like pretty low spec, like old laptop hardware. And then CSS Masks. This is something that is somewhat supported. The support is getting better all the time. This is where you can take if you have an SVG element that has some paths in it, you can use that as a mask to sort of mask away part of the video and do cool effects like that. This is sort of like a weird, like ghostly dream effect. And then, oh, I lost my mouse. Hold on here. One moment. There it goes. And then the last one is SVG filters. These are somewhat supported. They're supported in Chrome. The support matrix is a bit of a mess. I think Safari has a really hard time with them. And they're also something that I'm not sure if it's actually going to get better because SVG has been around for a while. And so if it's not better now, I don't know when it will be. But if you have users who are in Chrome, these are effects that you can use and they're extremely powerful. So I recommend checking out SVG filters and applying them as CSS filters. So that's our show. WebRTC has made it possible for theater artists to continue making a living during the pandemic. It's enabled collaboration between artists thousands of miles apart. We have artists from Boston, New York City, Baltimore is where I live, Florida, Minneapolis, Chicago, and San Francisco. Our audiences can attend from all over the world. We've had folks from Europe and even folks from like New Zealand and China. The benefits of this technology are available to indie creators just as much as they are to large enterprises, which is really cool. And if all this sounds cool and you want to check out, you know, some more of this stuff, we have a show coming up. It goes up on the 26th of March. It's called Welcome to the Hotel Fantastic. And you can find more information about that at hotelfantastic.live. So yeah, let me do a stop share here. I can check out the, oh, cool.
Really cool, Chris.
Question? Yeah,
I love it.
is Chris, any comments about the new, yeah, very cool. I also really like the CSS filters. I didn't know about them, so really nice to learn something new. And we have two questions. One is Chris, any comments about the new Lyra audio codec?
Oh, I had actually not heard about this. So I do not have any comments on it, but I will check this out. This is really cool. Thank you.
Okay, and the other one is the with the SFU. Couldn't there be a risk of bottlenecks on the server?
That is a risk. Yeah, and unfortunately, EC2 is very vague. Amazon is very vague about, like, you know, how much bandwidth does a VM of a particular size get? They often are just like, oh, medium, which is not specific. So yeah, you do need to do a bit of sort of like load balancing. I have found that bandwidth is very much the bottleneck. These servers never get up to like 100% CPU, but they do sometimes get into throttling. And having good tools like I often use, I think it's IFTop is a good Linux tool for measuring bandwidth and seeing if, like, you know, are all the bits that are coming in also going out, like, and actually getting numbers, because that's the first step in being able to debug that stuff.
Okay, thank you very much. Super cool. And with that, I think it flows nicely into the next speaker, which is going to be Kieran. Hi, Kieran.
Hello. Hi, everyone. I'm going to try sharing my screen. Let me see if it works okay.
Yeah, okay. We can see your presentation, so the floor is yours.
Great. So we have about 30 minutes left for the whole thing. So I'm going to try to take just about 10 minutes. I'm going to put on a timer and use our time wisely. So my name's Kieran. Until recently, I was at Bitmovin for a number of years, helping them build out some awesome future video streaming around compression, playback, and analytics. In fact, Armin from Bitmovin will be talking right after me. I just moved over to Vimeo, where I'm helping to lead an agency partner program. But what I'm talking about today has nothing to do with that. Instead, we'll be talking about some fun developments in web standards. So it's a kind of a nice transition after WebRTC. So I want to kind of leave you all with three things from this presentation. First, I'll give you an update on the WebXR standard and how it's evolved from WebVR. And then we'll zoom out a little bit and look at the market, and we'll ask the question, is it worth your time today to start learning some of these things now? And my thesis is yes, I think it is. And then finally, we'll look at volumetric video. It's a newer development, and there's a couple of pieces of hardware that are coming out that make this also worth at least understanding the basics of this so that we can see the right way to serve the consumer interest for it. So I'm going to be showing some slides that are from, I would say, a luminary or a leader in the field, Ada Rose Cannon. And so I give her credit for all of this stuff, but it's, you know, there's no sense in redoing the wheel. She has some good intro slides on what WebXR is. So we're going to start with those. She is involved in a couple ways. First of all, actually helping to co-chair the immersive web group that has developed the standard. And then she also produces some really awesome content as part of her developer evangelist role with Samsung, including some sample A-frame code. And we'll look at some of those things a little bit later. So what is WebXR? At its core, it's an API, and it's designed to access sensors and displays of immersive hardware. And that hardware is VR or AR or things that haven't been invented yet, hence the X on WebXR. And the challenge here is supporting the wide range of devices. And that's why the WebVR standard didn't sufficiently cover all the different use cases. And when you start to look at all the different pieces of hardware and use cases, it gets very complicated. There's a lot of permutations. But this makes it a little bit simpler when we think about three different types of use cases. One is head-mounted VR, and this is the VR that a lot of people are familiar with, that has a big old headset. You're, you know, invisible to the world. You can't see what's going on around you, and you have typically two controllers. Then there's head-mounted augmented reality. The HoloLens or the Magic Leap device are two of them, probably the most well-known head-mounted AR devices. Those may have controllers, but they may be hand controllers. And then handheld augmented reality, which is probably the largest use case by consumer numbers right now. It's growing very quickly, and we'll see some actual production examples of this. And this is also, it's a very valid use case. And so the challenge is, how do you create experiences that can go across this whole band? So kind of like, you know, adaptive display for CSS and breakpoints, all that fun stuff. You know, that same sort of thing can exist in the WebXR world. So literally, what does a WebXR do? What does it give you? API essentially gives you access to display WebGL content on the XR devices. And there's lots of specific gotchas when you dig into the details, such as the refresh rate of the device is likely very different than the browser DOM refresh rate or the tick rate of your JavaScript function. So already that starts to decouple some of the projection matrix of your camera from your JavaScript code, and life gets pretty complicated. The good news is, I'm going to fast forward a little bit, it helps you with controllers, it helps you with hand tracking, helps you with these convenience functions such as hit testing, raycast collisions, or putting DOM elements on the overlay. So these are all features of the WebXR API. Okay, well, that seems like a lot of stuff, and it seems complicated. Is it worth our time? And so I like to kind of make these connections to other technologies. And since this is a video tech meetup, I thought it would be helpful to kind of connect the dots here. Let's look at the history of online video, and then maybe we could figure out where does that put WebXR, and is it worth our time to play with this stuff? So when we look back at online video, we could start way back in 1928 with the invention of television, but looking more recently, it was really around 2010 where HTML5 video became a thing that was used pretty widespread, and it was really precipitated by the iPhone release in 2007 that required not using Flash, which was a big change for the industry. And it's progressed quite a bit since then. So where is WebXR in this? So there's two answers to this. From a technology perspective, I'd say we're around 2010 with relation, making the analogy to video playback as a first-class citizen in HTML5. And that's actually quite advanced. But here's the crazy thing. If we think about the medium itself, it's only really existed for at best 7 years in its most recent incarnation. So the Oculus DK1 was released in 2013. Whereas television has existed since 1928. So this is a fundamental different technology because there is no deep library of content, and the medium itself hasn't been invented yet in the way that it will be consumed. And I'll give you another example with television. If you look at 10 years after television was made, so in the mid-1930s, I was looking this stuff up, they were literally putting a camera in a theater, and that was TV. Like, let's just televise a play. Not moving the camera, the audio was horrible. None of it was actually made for television like we think of it today. And that's really the stage we're at in terms of like the product or content development of XR and AR. We have no idea what we're doing. And it's interesting then in this context that the standard is actually moving faster than the content that's available for it and the devices. So speaking of which, what's actually available to use this stuff on, I'd say the best experience is really the Oculus Quest devices. And if you all are interested in this stuff, I would absolutely recommend picking up the Quest 2 if you get over the whole Facebook stuff. It's an excellent device, and it treats WebXR as a first-class citizen, and it works just great out of the box in the built-in browser. Highly recommend it. Another good experience for WebXR is actually mainstream Chrome on Android devices that are top tier. And so they have high quality cameras that meet Google standards for AR Core, which is the underlying hardware API that WebXR plugs into using the browser. So Samsung, Google Pixel phones, those all support true WebXR in Chrome today for very high performance handheld augmented reality experiences. And then AR head mounted, the HoloLens team has confirmed that this calendar year they will complete their WebXR integration. Magic Leap already had support for this. On the VR side, there's also PC tethered, like with a wire to your computer, but that's not a market worth going after. And then the big iPhone moment here is that Apple, through signaling through WebKit, is saying that they are going to be integrating at least some of the WebXR components into WebKit. This is very significant. And I think that the question now is how and in what devices, and does this connect to all the rumors of some sort of head-mounted display for Apple. So then how do we deal with all the complexity? There's a lot of stuff going on. And how do we deal with this in online video? Well, what happened was that there were essentially player frameworks that came out, first in the Flash era, and then as video transitioned to an HTML5 standard. And similarly, there are frameworks, and that has some similarities to the analogy of a player. There's a bunch of different frameworks, but my personal favorite is A-Frame. A lot of these are based on Three.js, so A-Frame and React 3 Fiber at their core, they're kind of like wrappers or higher level abstractions on top of Three.js. Babylon.js is a great project at feature parity with Three.js, actually maintained by a team at Microsoft. Unity has a much improved WebXR export, so you can actually use that to make high quality experiences and export them from Unity that are WebXR compliant. So like I mentioned, there's kind of all these different stacks. I was focusing a lot on the WebXR API itself in this presentation, but again, you have layers on top of it to make this much easier for you. So quick answer, I think it's worth learning about. Now real quick, I only have 1 minute left, is volumetric video. And why is this important? This is a photo of one of the new iPhones that has LiDAR in it. This is enabling a very interesting use case. There's another product release that's happening from Looking Glass, which is a $300, which is a consumer price point for a 3D display called the Looking Glass. And this will enable 3-dimensional video without any hardware. It's a very nice device. And I'm very curious to see how the market demand is going to actually use this. The Kickstarter was very successful. They've already built much larger devices, so they're going to be able to produce a lot. And so then the question is going to come up, how do you transport this stuff? What's the right way to do it? There's basically 3 different ways. There's RGB plus depth, there's streaming mesh, and there's multi-view. And I'm going to go through this super fast. What you're seeing here is an example of multi-view. This is a previous generation of the Looking Glass device. This does overlap with my employer, Vimeo. They did a lot of work on how to get this stuff to the device. And this concept for the Looking Glass, this one's called multi-view, and it's literally multiple views. This is a 9x5 grid of 45 different angles, 45 degrees that fit within the display capabilities of the Looking Glass device. The next possibility for transporting this stuff is RGB plus depth. It's basically similar to a point cloud, but not exactly a point cloud. You can convert a point cloud into RGB plus depth. There's 2 different tracks. There's the texture. This is an example of actually volumetric. This is RGB plus depth working in A-frame, which is WebXR, so connected to different worlds. And you can just see this is an example freeze frame from the RGB plus depth method. And it's worth noting that it's not just grayscale, but they use the full RGB color gamut to define the depth, which gives them more latitude. I'm 1 minute over, we're almost there. Volumetric video streaming mesh. This is something that Microsoft has done a great job with. The format itself is excellent. We don't have time to go through the technical demo of it, but you can see the output and how it's being used in production environments. This is an example of WebAR used for high-class, premium advertising content. This is an example that works on almost any device. This is also powered by a company called Eighth Wall. So this is very good. The downside of this method from Microsoft is that it is extremely production intensive. So it's not easy to produce, whereas RGB plus depth, it works on your iPhone. So there's positives and negatives to all these different strategies. So that was volumetric. We've gone through the whole thing. How do you get started? I highly recommend A-Frame. This is a literal snapshot of how the scene on the right is rendered. That's it. And it essentially abstracts it so that it's a declarative HTML-like syntax, very easy to learn. And you can just go to aframe.io. And then I also worked on a series about creating 3-dimensional street visualizations using A-Frame and all this stuff. And so if you go to bit.ly/webstreet, I can paste that link in the chat. There's a tutorial on essentially creating a bunch of content for WebXR experiences. So you can create that by following the guide. So with that, I will pass it off to Armin.
Thank you, Kieran. Super, super cool. And it's nice to see how this will develop in the future. So really forward-looking kind of new reality. And I think also it's interesting to see the data rates that these technologies will need to be supported correctly. If you look, for example, at Melody VR, which does interactive concerts, and one of the complaints that the user have is that the quality of the video itself is not good enough. So I think there will be definitely a development as the internet connection speed and data rates will increase. But yeah, very interesting.
Yeah.
Thank you. And with this, I will pass it on, and some comments in the chat, so that's good. And with this, I will pass it on to Armin to talk to us about shot-based encoding. So Armin, the floor is yours.
Thanks, Andrea. Can you see my screen? Awesome.
Yeah.
Yeah. Now to to something completely different. Back to good old encoding and some basics. Yeah, all this volumetric and all amazing things need to be encoded at some point, and it's always good to think about to make it more efficient. Also, just on the backhand side, and yeah, there's still some stuff we can do. And one thing is shot-based encoding, and then I will try to explain this a little bit. My name is Armin. I'm working at Bitmovin at the encoding product. And yeah, let's get into it. First of all, I want to refresh some memories about keyframe, picture types, and group of pictures. So as you all know, a video stream consists of usually a group of pictures that's like from one keyframe until the next keyframe. The keyframes are usually all intra-coded, so they could also be still pictures, and they usually at the beginning of a GOP, and all the other frames that are encoded reference back to them or reference other intercoded frames. There are P frames, which basically also reference in the future, and P frames, which reference back in the previous frames. Yeah, this is important to understand the shot-based concept. Yeah. Then I also want to refresh the memory on adaptive streaming. So you all know adaptive streaming works by splitting up the whole video or movie that you're watching into smaller segments. Usually they are 4 seconds or 10 seconds long, and they're basically stored in different representations on the server. And depending on the bandwidth on the client selects the optimal representation for the current situation to avoid like playback stalls and issues, and yeah, be really adaptive and flexible. And it's proven to be really good and basically standard now for web streaming. And yeah, this is important to know, because if we do encoding now, we at Bitmovin, we do distributed encoding in the cloud. So we usually encode each segment for adaptive streaming on a separate instance. And yeah, we have to split them up by a fixed amount of seconds. Usually it was like that. And traditionally it is like that each segment has the same number of frames and has the same duration. But this could be different. It is also allowed in the streaming standards like Dash and HLS that we could also have a different duration for these segments. Okay, what is now fixed and variable segment duration? If you look at this group of pictures of the basically unsegmented video segments, what you can see, if you chunk them up into fixed segment durations, we look at the iframes we need to place. So at the beginning of each segment, we have to start with an iframe, because it needs to be a like decodable unit. You need to have an entry point at the beginning of a segment. Yeah, and if we see, we need to place some extra iframes on the segment boundaries. And yeah, once the idea is that we align the segments or the iframes with the naturally placed iframes. Yeah, basically I just want to recap. Usually in encoding, we place an iframe whenever it is necessary. So when the difference becomes too big, for example, at the shot boundary, when the camera switches, we place an iframe because it makes the most sense at the position. And if we now align these segments with these shots, we have fewer iframes in total and can save some bandwidth here. Here's an example with Big Bug Bunny. If you look now at the middle stream, that's where the variable segment sizes are used, and the shots at the top align perfectly with the segments of the adaptive stream, and we don't need to place any extra iframes there. And at the bottom, there's the example for the fixed video segments with 4.5 seconds. And you can see we need to place some extra iframes at some positions where basically there's no natural, for example, here, there's no natural shot boundary, and we need to place an iframe here. So this could mean that we are unnecessarily placed an iframe, which wastes bandwidth. Here's again an example just to illustrate how this could look like in the stream. So at the top we have different sized segments, and at the bottom the fixed segments. And yeah, to summarize the potentials here, we could have fewer iframes throughout the whole asset, and therefore we have potential bitrate savings. So usually we save a lot of bitrate if we have big group of pictures, so we don't use as much iframes. We use lots of B and P frames that reference to these iframes, and therefore the equation is less iframes means more bitrate for difficult parts. So there's some first experimental results. If we count the number of iframes in a stream, I have some results for Big Bug Bunny, Tears of Steel, Meridian, and another stream. And we see from some use cases for Big Bug Bunny, we can almost halve the number of required iframes. This does not unfortunately translate that we need half the bandwidth to encode, but it's still an impressive comparison. So we actually were curious about this shot-based approach and did some experimental results in our own encoder at Bitmovin, and wanted to test it out if it actually works and we save some bandwidth. And here we have a ladder for an adaptive stream and encoded it with CRF22. So the goal was to have a constant quality or the same quality for each representation. And we see here in the VMAF score, almost all representations have the same quality but use less bitrate. And the total PD rate gain this means that for the same quality, you need about 6.7% less bitrate, just if you switch from fixed segment size to variable fragment size. And I think this experiment was done with a minimum segment size of 2 seconds and the maximum of 10 seconds. So do not go crazy with the shot detection. Yes. I want to also explain something about the setup and the parameters we considered. I explained that the minimum and maximum segment duration plays a role because you cannot go too crazy on that. For example, some shots are just a few frames long, and the encoding efficiency would be really bad if you just encode a few frames. So it makes sense to also combine some shots and to have a minimum segment duration. But also if they are too long, it could be an issue for the adaptation logic in the client. It would be boring for it to download like a 60-second shot, and it would be also terrible for the startup time, for example, things like that. And also interesting topic is the shot detection algorithm. So what we usually need to do is we need to, before segmenting or distributing this encoding, we need to determine, yeah, what's actually which frames belong to which segment. And it's kind of easy if they're all the same size, but somehow you need to find out where the shots are to make the smart decision. And yeah, the naive solution would be like the FFmpeg filter, where you need to decode the input stream and basically compare the frames step by step with each other to find the shots. And for a first demo version, this was good enough. For example, here's the FFmpeg filter. It just has a threshold of 0.4. That means if the one frame differs 40% to another frame, it detects a shot. But there are also other interesting and better shot detection algorithms there, which could improve even that. Okay, then I also want to address the playback with variable frames, with variable segment sizes. Traditionally, they have been the same duration, and most of the adaptation logics of the players are tuned to that. So they expect kind of the same segment duration for all segments. And yeah, this could be an issue depending on the adaptation logic. There was some research done that showed, okay, the quality of experience was increased nevertheless with variable segment sizes because of the reduced bitrate. So like in an experimental setup where the bandwidth varies, it scored a better score compared to the fixed segments. But it showed an issue that it could stall when there's a really long and complex shot and the player tries to download it and use lots of bandwidth for it. And when during that time the bandwidth drops, it can have a negative impact on these results. So would be also interesting to do some further research there that, for example, for really complex shots, you split them further to increase the adaptation. The possibility to do adaptation in that case. Okay. I also want to talk about per title and the potential for per shot encodings. In our experiments, we just aligned the segments with the shots for the stream, but you could also do some per title on each of these shots. Just to recap, per title encoding means that you basically dynamically create the encoding ladder, so the renditions, the representations, and the bitrate for the adaptive streaming based on the input asset. And you could also do that based on each shot. So imagine you have some news content and just have a talking head for 30 seconds, which is easy to encode. And then they show some action scene from a trailer or something, which is really hard to encode. You can split it up into two shots and have the per title optimization on each of them. And the technology that would make that possible is the multi-periods for Dash, which is traditionally used for ad insertion. And you could just make a period for each new shot and do the per title optimization there. So it shows also further potential just with compared to the bitrate savings you get out of the pad. Yeah, that's just my conclusion here. I think I can skip that. And also a short point: we are hiring at Bitmovin, and check out our career page if you're interested. And that's already it. Thanks.
Thank you. Very interesting about shot-based encoding and selecting the proper, more natural iframes. So we have a couple of questions. The first one is, what about fast forward or positioning in a stream?
You mean the trick play, basically seeking and stuff? That depends on the implementation. I think usually Apple uses the iframe playlist to do that, and it would be just mean the same, that you basically that the iframe playlist is not aligned, like you have a iframe every 2 seconds, but you have it every 1.5, then you have one in 4 seconds, so they are not at the same positions. But I think for the granularity of the seeking, it's also good enough if they not align with the seconds in the fixed position all the time. It would still work.
Okay, thank you. And the second question is, if I position the playhead, how do you get the iframe?
I think this is targeting the seeking again. Yes, same as for the traditional approach. I think depending on the player, it downloads the corresponding segment to that timestamp and starts playback from, or decoding from the first IDR frame in the segment, and seeks to the until it reaches the exact playhead position. And it could take a bit longer if you're unlucky, if like you have now a really long shot compared to the fixed one, but usually it shouldn't impact the experience too much.
Okay.
Yes,
Thank
segments are variable in that case, to follow that up.
Yeah, okay, thank you. And we have one last question from Baba. Please, thanks, Armin. If there is any impact, how would shot-based encoding approach impact the ad insertion, and also about the dash periods?
Yeah, I think there's like 2 different approaches to ad insertion. There's server-side ad insertion, where it would just be in the encoded stream, so no issue with the manifest. And there's the client side, where you basically have inside the manifest some clues or indications that you could start an ad here. And yeah, that would just mean that for the same kind of stuff at the position where you want to place an ad, you could make a custom segment boundary, for example, configured by the API of the encoder, or just put it inside 2 segments if it's convenient, I guess.
Okay, great. So thank you very much. And if there is any more questions, we have run a bit over, but they were all very interesting, and I really enjoyed them. And I think that they reflect what's coming in something, or what's coming in video for the next coming years. So I want to thank you everyone as well. And I just want to say that we will have a recording on YouTube in some time, and we will message the rest of the group when it's ready. So thank you again, and have a great evening. Thank you. Thank you, everyone.
Bye.
Bye.
Grazie.
Bye, everyone.
Ciao.